Now we know from the previous video that once we put that magnetic load on the coil being empowered, that coil is going to power the Tesla primary. Our input voltage dropped by 20% to 20 some volts. And now we're only procuring 3.7 some milliamps. At this stage of the game, if we wanted to hook the line connections from that resonance up to power the Tesla coil, we would understand that it would be highly inefficient. We're better off to obtain the power through the air. When we obtain the power through the air, from that input there, we acquire 15.4 milliamps and the voltage almost 100 volts there. Oh, wait a minute, it's not even hooked up. What's going on with that? Well, since everything's do not understand why that voltage meter, in fact, that's in millivolts. I'm sorry folks, that's in millivolts. We're going to put our voltage probes on the arc bars. Looks to me 109 and some volts through the arc bars. That's going to fire our arc gap when in fact we turn the field on. Okay, now we're going to go turn the field on. Make sure the camera caught that. I've had to do all these deductions myself. I don't even think that we caught that, did we? We might have caught it. We'll let it go on review. Okay, now we're going to come over here to the Tesla coil itself. Those arc bars power the primary in a conventional manner, and because there's no transformer, we're operating the Tesla coil at the very minimal amount of energy, and it's actually surprising that we can actually even operate the Tesla coil with an arc gap. So what we've done then, back out of the situation here. What we've done is we've hooked the neon to the top globe. This thing functions at 250,000 hertz, light signal generator tests. And since we're operating at such a meager power level, we're not going to be able to see any conventional Tesla type arcing as you would normally see in a Tesla coil. But we do have a neon hooked to the top globe and the base of the secondary. Now we'll go on in there and we'll turn that on. And our ground come on connected. We'll have ground again. Okay, there's our neon lighting. Here's our arc gap. And that's when we do this, things equal out between our input and our output. We have hard to see where we're at here. We have about 120 volts going in, establishing a very fluctuating 20 to 30 milliamps. And then we have a little bit of glare there. We have about 93 some, almost 100 milliamps going through there. That's exciting, the arc gap. Now we want to look at our input conditions. Whenever we have an arc, this creates havoc with the meters. I see that one of the meters is showing 0 turn on the delivery lines. That don't make a lot of sense. I do not know why that is happening. And when in fact we operate a Tesla coil, it wreaks havoc on any kind of meters. As a matter of fact, we're showing 4.5 volts on phase 1, 18.5, 19 volts on phase 2, and 0 volts. There it went up to 13. Oh, it's all over the place. And here are some of our other interphasal amperages that we're not yet attached to. I think we've covered everything pretty well, except now we're going to go turn the device off. We're going to turn the field off. Before we turn that field off, let's look at our bulb one more time. You might be able to hear the arcing. I don't seem to be getting a real good camera reading of that bulb for some reason. I can plainly see that it's lit, but it is sunlight. Neons are hard to observe in sunlight. I don't know why we're having such a hard time observing that. Perhaps it's in the glare. There we go, I can see it now. Okay. Doing a pretty good job of lighting that neon. Okay, now we're going to go shut the field off. Now we're going to try to finish out the video. We see that it's wreaked havoc on that thing there a little bit. It's kicked out our amperage meter on our AC amperage meter measurement. Once again, we have 3.5 milliamps going through there, and I'm going to go back and look at this. Put our voltage meter back up there. Well, we don't need the voltage meter, I don't suppose. Watch what happens if we can see all of these meters and why it quenches the arc efficiently. I don't like that glare on that meter. I don't think anyone can see it. My fans out there. Oh no, I'm a mad scientist. Okay, we ought to be able to see that. Now we need to find the coil short something else here. Watch what happens when we short the arc bars out. Our supply is at 18.8 volts times 3.5 milliamps, curing 14 milliamps. Here's the short. See that meter, when we shorted things out, our supply went down to 3-some milliamps, and we're back to a low condition on the primary supply pretty much. And what this does, it enables the arc to be quenched. The voltage is reduced upon formation of the arc. I think that covers everything else. Now we're going to the finishing stages here. We're going to call on 16 people. Become the initial Majestic 16 investors, and the cost of their investment is $25. For that $25, you shall receive 2 hours of video explaining everything concerning what the time distortion invention is and how it is based on a magic square technology. Thank you.